Hey everybody, I wanted to run through this multiple choice practice here to make sure that we feel totally comfortable with what's going on in AP Physics as far as getting ready to take that AP exam in May. The time goes quickly, especially with college apps and other classes, so we just want to make sure we're keeping a good pace and really preparing you with some good physics overall. So here we go. We have this overall picture here. A truck traveling 400 meters north in 80 seconds. And then 300 meters east in 70 seconds. And we want the magnitude of the average velocity. So we've got 300 meters here, 400 meters here. So the displacement of the truck is from here to here. And using Pythagoras' theorem, that's a 3, 4, 5 triangle. The total time is 150 seconds. So our average velocity is going to be displacement over time, which is going to end up being 3.3 meters per second. Right there. Incidentally, if we ask for the average speed, that would be distance over time. The speed would be 700 divided by 150, which ends up being, let's see, 14 over 3. So that's, hang on, no, 16, yep. Let me try this one more time. So 70 divided by 15, so that's 70 divided by, that's going to give me 14 over 3, which ends up being 5 point something, so that's not even a choice on there, so that's the speed. The velocity is 3.3 meters per second. Now, for number 11, we have a projectile fired with an initial velocity v0 at an angle of theta with the horizontal, and it follows the trajectory shown above, and we want to know which paragraph represents the vertical component of velocity and acceleration. You know, one thing, the trick to this problem is I don't even read the problem carefully because they give me this projectile motion plot or picture, whatever you want to call it. And then they give me these graphs here, so I don't even need to look at the problem. It's clear to me that they want me to pick the correct velocity and acceleration. Now here's the thing. When you launch a projectile into the air, it turns out the only acceleration that acts for a perfect projectile is gravity going downwards. So we need a constant negative gravity for our acceleration graph. So we can actually eliminate choices that don't work. That rules out choice A, choice B. Now C, that's 0 acceleration. E doesn't work either. Only choice D works. Another way to look at this is that we can actually eliminate graphs based on slope. The slope of the velocity graph is the acceleration. So you notice this is not the correct slope. Not the correct slope. Not the correct slope. This is the correct slope of the velocity graph, but it's not the correct physics, so that leaves us with choice D. All right. Now we have an object released from rest on a planet with no atmosphere, so I'm going to skip the formalities of writing out every single variable for this equation and just tell you that when you have something falling, take downward as positive, and then just plug in your number. So we have 3 is 1/2 a times t squared, which is 1 squared. And so when we solve for a, we end up getting 6 meters per second squared. Now lastly, questions 13 and 14. Let's be clear. When you're at the same height, P and R have the same speed. And Q is where it's at its slowest. So what we need is VP and VR to be equal, which eliminates choice A, B, C. And then the other thing is VQ is where it's at its slowest. So that leaves us choice D. And once again, based on our reasoning from before, when you launch a projectile, the only acceleration you have is due to gravity, which gives us choice E. So that's it for the multiple choice questions. I hope that was helpful. We'll always be practicing a little bit of multiple choice, a little bit of free response as we get into that, just to give you some AP practice and really to reinforce some of the physics that you learned last year.